Good evening, Internet. I am Matt Buyak, and in this video, we'll take a look at the 22nd problem from the Project Euler problem archive. Now, this problem gives us a list of 5,000 names and asks us to sort it and then score each name based on a formula and its position in the list. Our answer is then just the sum over all the scores of all the names. So I've already downloaded this names.txt in preparation for this problem, so let's get into it. As usual, we'll copy our template directory to make our problem directory. And we'll need to copy that file that I mentioned from outside Windows Subsystem into our problem directory. Okay, and let's get started. So first, let's open up that. Actually, let's rename this file. It's kind of awfully named. So let's move that to just like input.h. Okay. And Emacs is going to choke on this a little bit. It's pretty good with large files, but it's still gonna be a little bit slow. Okay, and we're going to need string and vector. Wait for it to catch up there. Okay. So now we're going to make this just a vector of strings okay. Yeah, the alternative to doing it this way would have been to actually keep this as a separate file and do the input parsing as part of our program. Oh, this should be an array. There we go. No, it's a vector. It's a vector. Okay, so I think that should be good to go. Let's go back to our main.cpp. And we'll include input.h. So the first thing we want to do, in the problem description, we were told that when the list is sorted, colon should be the 938th name in the list. So we want to verify that we've read the list correctly and sorted it correctly. So we'll need algorithm, and we'll say sort input.begin input.end. So this is just a standard STL algorithm, and these are the iterators to the begin and end of our input. As usual, for more details, you can go to cppreference.com and see all the gruesome details of that that template. Okay, so now we should be sorted. Let's check to make sure that the 938th element is as expected. So we'll say %s. Now, one point of caution is that the first name will have index 0, so the 938th name will have index 937. So we'll say input 937 dot cster. So the STL string class just wraps a standard C-style string, and to get that string, you just use this function here, cster. Okay, so let's make. You can you'll notice it takes significantly longer than it typically does because of that large header file that we're including. Okay, and we can see colon here. That's what we expect. Okay, so let's continue. So the problem asks us to score each name by adding up the letters interpreted as numbers. So the third letter counts as a 3, the 15th letter counts as 15, etc., etc. And so we'll just want to write a little helper function here. Call it score. And that will take a constant string reference. And then we can just say uint32t sum equals 0. And we'll say for character ch in s. Then we'll just say sum add ch minus a plus 1. So as I mentioned in a previous video, each of the printable characters corresponds to an ASCII symbol. And each ASCII symbol has a particular value. And so the easy way to find where a given character falls in the alphabet, if you know that it's an uppercase character, you can just do this subtraction like this. Note that that will map capital A to 0, and we want to map it to 1, and so we'll just add a 1 to make that mapping what we want. Okay, then we just say return sum. All right, so now we'll need to iterate over all of the strings in the list, get the score of each, and sum them all together. So we want uint32t sum equals 0. We'll also need an index. You'll notice that once we've added the numbers to get the sum for the particular name, we need to multiply that name by its position in the list. And again, that position is 1-based rather than 0-based. So the 938th name has it was multiplied by 938, not 937. So we'll just need to be careful to do that correctly. Okay, so we'll say I is going from 0 to input.size. And then we'll say sum plus equals I plus 1 times score of input I. And then we'll just say return sum. Oh, excuse me, not return sum. Print. That should take a moment. Okay, so that gives us an answer. It looks like 871,198,282. So if we go back to the archive and check our answer, we'll see that that matches our expectations. Okay, so that's it for problem number 22. The next video will be moving on to problem number 23.